Hello everyone, welcome to our channel Clear and Concise. In this video, I am explaining you ISRO Mechanical Engineering previous year questions with solutions. A thin circular disk is rolling with a uniform linear speed along a straight path on a plane surface. Consider the following statements in this regard. For a rolling disk shown in the figure, velocity varies with the position. It is maximum at the top of the disk and minimum at the bottom of the disk. So velocity is not same at the all points of the disk. And when it comes to the acceleration at center of mass moves with the uniform linear speed. So acceleration is 0 at this point. When it comes to bottommost point of the circle, here linear acceleration is 0 and there might be a centrifugal acceleration. If the angular velocity is also uniform, then there won't be any acceleration at that point, but we are not so clear whether angular velocity is uniform or not, so we can't properly say that whether the acceleration at the point P is 0 or not. Now, and another thing is the centrifugal acceleration at the center. Centrifugal acceleration is given as mr omega square. At the center radius is 0, so Fc is equals to 0. If centrifugal force is 0, then centrifugal acceleration AC is equals to 0 at the center. If we observe the options given here, all points of the disk have same velocity, which is not true. Velocity varies with the position. The center of the disk has 0 acceleration. Yes, it is true because it is moving with the uniform linear speed. The center of disk has centrifugal acceleration, which is false because centrifugal acceleration at center is 0. The point on the disk make contact with a plane surface has 0 acceleration. It may or may not be 0. If angular speed is uniform, then it is 0, otherwise it is not. So we cannot say anything about this point. So if we observe the option D seems to be correct. Next question. If a number of forces act on a rigid body, each force may be replaced by an equal and parallel force acting through a fixed point together with a couple. For a rigid body to be in equilibrium, the forces acting on the body and couples should vanish. So, summation of forces on rigid body should be equals to 0 and summation of moments about a fixed point on the body should be equals to 0. So, the correct answer is option A. Both resultant force and couple must be equals to 0. Moving on to the next question. Whirling speed of the shaft coincides with the natural frequency of its. Whirling speed is the rotational speed of the shaft where the natural frequency matches with the excitation frequency, which causes resonance phenomena. At resonance, shaft vibrates violently in the direction perpendicular to the axis of the shaft, that is in transverse direction. So the correct answer is option B, transverse vibration. Next question. A fixed gear having 200 teeth is in mesh with another gear having 50 teeth. The two gears are connected by an arm. The number of turns made by the smaller gear for one revolution of arm about the center of the bigger gear is. In order to find that, it is simply N2 is equals to 1 plus T1 by T2. That is equals to 1 plus T1 is number of teeth on bigger gear, that is 200, divided by T2, that is number of teeth on smaller gear, that is 50. 50 ones are 54s are, that is 1 plus 4 equals to 5. So smaller gear makes 5 revolution for 1 revolution of arm. Option D is the correct answer. Next question. With the symbols having the usual meanings, the single degrees of freedom system mx double dot plus cx dot plus kx equals to f sin omega t represents. The given equation consists of external force term f sin omega t and damping term cx dot. So it represents forced vibration with damping. Option C is the correct answer. If we further reduce this equation like this, mx double dot plus cx dot plus kx equals to 0, here there is no external force term, so it represents free vibration with damping. That is option A. Now further reducing this equation, mx double dot plus kx equals to f sin omega t, here there is a external force term, so it is a forced vibration, and there is no damping term, so it is a forced vibration without damping. Forced vibration without damping, that is option D. This equation represents option D. Now let's see this equation. Mx double dot plus Kx equals to 0. Here there is no external force term, so it is free vibration, and there is no damping term, so this is free vibration without damping. Free vibration without damping, that is option B. This equation represents option B. Next question. In the two rotor system shown in the figure, a node of vibration is situated at. First of all, node is a location with 0 twist. Now, if there exists a node in between two rotors, those two rotors act as two different systems with same natural frequency, F1 equals to F2. Now, let's assume if there exists a node in between these two rotors and the distance from the first rotor is L1 and the distance from the second rotor is L2. Now, let's find the relationship between L1 and L2. With that, we know F1 is equals to F2, which yields omega 1 is equals to omega 2. For the rotor systems, we have omega as square root of KT1 by I1 is equals to square root of KT2 by I2. Here K is torsional stiffness, which is given as Gj by L. Substituting that in the equations yields square root of Gj by L1 I1 is equals to square root of Gj by L2 I2, which yields L1 I1 is equals to L2 I2. Now, L1 by L2 is equals to I2 by I1. L1 is equals to I2 by I1 times L2. We know I2 is greater than I1, therefore L1 is equals to some constant C which is greater than 1 times L2. Therefore, we can clearly say that L1 is greater than L2. So, the correct answer is option B. Node is located in between I1 and I2, but which is near to I2 because L2 is smaller than L1. So, the option B is correct one. Next question. Which of the following is not a friction clutch? A clutch is a mechanical device used for power transmission between two rotating shafts. When it comes to disc cone centrifugal clutches, they use friction surfaces for power transmission. That's why they are called friction clutches. When it comes to jack clutch, it uses teeth. Interlocking of teeth enable precise control over power transmission. That's why it is not a friction type of clutch. So, option D is the correct answer. Next question. Polar moment of inertia of a circular disc is to be determined by suspending it by a wire and noting the natural frequency of oscillations. We need to find the relationship between polar moment of inertia and frequency of oscillations. We have omega is equals to square root of Kt by Ip, that is polar moment of inertia. Kt is torsional stiffness, omega is angular frequency. Now, we have omega is equals to 2 pi f. So, 2 pi f is equals to square root of Kt by Ip. Now, squaring both sides, f square is equals to 1 by 4 pi square times Kt by Ip. From this we can state that Ip is directly proportional to 1 by f square. The correct answer is option A. Next question. Pick up the wrong statement about flywheel. Flywheel is a mechanical device that stores rotational kinetic energy and releases whenever needed. It reduces the speed fluctuations and regulates the speed by supplying stored energy in low energy cycles. So, the wrong statement is controls the mean speed of rotation. Flywheel is not at all used to control the mean speed of rotation. So, option B is the correct answer. Next question. Purpose of using differential gear in automobile is to. Option A is the correct answer. Differential is used to help in turning because while taking turn, the outer wheel has to travel more distance than inner wheel. So, the differential gear helps in maintaining differential speeds so that the turn takes place smoothly. Next question. The acceleration of simple harmonic motion of a pendulum is proportional to. In simple harmonic motion, force is directly proportional to displacement. Here F is restoring force and X is displacement from the mean position. It always acts in the opposite direction to the restoring force. So here the negative sign signifies that. Now for pendulum, we know theta double dot plus square root of g by L theta is equals to 0. Here theta double dot is angular acceleration and this theta is angular displacement. We can clearly state that angular acceleration is directly proportional to the displacement theta. The correct answer is option D. Similarly, for any system which executes simple harmonic motion, force is directly proportional to displacement. So, acceleration has to be proportional to the displacement. Next question. A person walks up a stalled escalator in 90 seconds. When standing on the same escalator, now moving, he carried up in 60 seconds. How much time it would take him to walk up the moving escalator? For that, simply take 90 times 60 divided by 90 plus 60. We will get 5400 divided by 150. 0 gets cancelled. 15 ones are 15 3s are 45 and we will have 90, that is 6. We will get 36 seconds. Option B is the correct answer. Next question. A stone of mass m at the end of a string of length L is whirled in a vertical circle at a constant speed. The tension in the string will be maximum when the stone is at. We need to find the position of stone. Let's consider when the stone is positioned at the top of the circle, its weight acts always downwards, that is mg, and centrifugal force pulls it away from the center, that acts outwards, which is mr omega square. Now tension in the string is always towards the center, so T is equals to mr omega square minus mg. Because mg and tension both acts in same direction, so T plus mg is equals to mr omega square, which in turns gives mr omega square minus mg. Now if we apply the same condition to the stone when it is at the bottom, we will have tension acts upwards, weight acts downwards, and centrifugal force, which always pulls away from the center, acts downwards. So tension is equals to mr omega square plus mg. Now we can clearly state that when the stone is at bottom of the circle, it has maximum tension in the string. So the correct answer is option D. Next question. Speed of a particle executing simple harmonic motion with an amplitude a is half of the maximum speed. At that instant, displacement of the particle is. Displacement of particle is given as x equals to a sin omega t, where a is amplitude of the motion. Now velocity v is equals to derivative of displacement with respect to time, that is equals to a omega cos omega t, because derivative of sin omega t is omega times cos omega t. Now the velocity is maximum when omega t is equals to 0. So a omega cos omega t, that is 0, that is equals to a omega. Maximum speed is a omega, but in the problem it is given that at some particular instant velocity is half of the maximum speed, that is equals to a omega by t. We need to find angle such that the speed is half of the maximum speed. For that, let's substitute in the velocity v. We will have a omega by 2 is equals to a omega cos omega t. omega gets cancelled. Cos omega t is equals to half. It is possible when omega t is equals to 60 degrees. Now substitute this omega t equals to 60 degrees in displacement. We will have x is equals to a sine 60 degrees. Sine 60 is root 3 by 2 and a. So the correct answer is root 3 by 2a, which is option B. Option B is the correct answer. Next question. Two satellites of masses m and 2m are on the same circular orbit around Earth. If the velocity of lighter satellite is v0, what is the velocity of heavier satellite? For satellites rotating around Earth's orbit, centrifugal force Fc is equals to gravitational force Fg. Fc is defined as mv square by r, where m is mass of the satellite, v is velocity of satellite, r is Earth's orbit radius. Now, gravitational force Fg is equals to gmm by r square, where capital M is mass of the Earth and g is gravitational constant. Now, m gets cancelled, r gets cancelled, v square is equals to gm by r, which is equals to v is equals to square root of gm by r. Equation clearly shows that velocity v is independent of mass of the satellite m and 2m. So both the satellites will have same speed in the Earth's orbit, which is v0. Option B is the correct answer. If you have any questions, please reach me out through comments. Do subscribe to the channel for more interesting videos.